All, as I have discussed in my previous videos and the syllabus of discrete mathematics and important topics. So today in this lecture I am going to explain you those important topics that I have already started in one of my videos in which I discuss about the principle of mathematical induction. And if you have not watched that video, please go to watch that video on principle of mathematical induction, and I have explained each and every step of mathematical induction with the help of two examples. So today I'm going to another important topic, which is if I show you that PDF of your syllabus, and which right this here in unit 1, these are the important topics, which are logical connectives, disjunction, conjunction, negation, and conditional connectives. So I'm going to this much portion, and this portion is very important, as if you look for the previous year papers, and you will find that 2 to 3 questions are asked from this portion. So without wasting a minute, I'm going to start with this portion. So first of all, I will tell you the definition of conjunction, right? Conjunction. So what is conjunction? And this conjunction between the two prepositions, let P and Q, right? P and Q. So conjunction is denoted by this. So you know what is prepositions. Prepositions are the statements actually that are true or false, right? So P and Q are both the prepositions, right? So conjunction of P and Q is denoted by, let P and Q be two prepositions, and prepositions and conjunction between P and Q, is denoted as P and Q, right? So this is the symbol. This is the symbol of the conjunction is this, okay? And as I just told you that prepositions are either true or false. So if I create a truth table of by taking the values for P and Q, so there are 4 possibilities. If I take true or either true or false for both these, so it will be like true, or the both are true or both are false, or one of the prepositions is true and another is false. So so P is true or Q is false, or P is false and or the Q is true, right? And the another possible combinations will be false and false. So if I write this as with the conjunction P and Q, so that will be true and true will be true, and true or false is false, false and true is false, and false is false. So it means that that conjunction P and Q is true only if both P and Q are true, right? So अगर P और Q दोनों ही true होंगे, तभी क्या होगा, जो कंजक्शन P and Q है वो true होगा, ठीक है? तो this is the definition of conjunction, and It is very important to know these definitions of conjunction, disjunctions, and other logical equivalence. And if P then Q, this type of relations, P or your exclusive or. Because if you know these basic things about the prepositions, so you can solve or prove some statements. Okay. So I will show you some examples, right? So let's talk about the another prepositional functions or logics, like this is your disjunction, right? So disjunction is denoted by this symbol. This is the symbol for or, and disjunction is denoted by this symbol, right? Or right. So the disjunction between two prepositions, which is P or Q, will be true, or is true, you can say is true if one of the prepositions when one of the prepositions, either P or Q or both are true, right? Both are true. Okay. So if I write the this in a truth table, right? So again, the two possible combinations for true or false will be true when P and Q are true, when P true, Q is false, when Q is false and P is true, right? And then this is okay, this both are false, right? Both are false, so let me write it here as, okay, write it here, right? Now write this P or Q. So as I just told you in the definition, either P or Q is true or both are true. So here in the first case, when P and Q both are true, so it will be evaluated to true. And when P is true and Q is false, so one of the statement or one of the prepositions is true, so it will be true. And again in this case, it will be true. And but here in the last case, when both are false, it will be false. The disjunction of P or Q will be false, right? So this is your disjunction. Disjunction is like your OR gate in digital electronics, if you have studied digital electronics. And if you have not, if you don't have any knowledge about the logic gates and or not, it's okay, no problem. So but for just to connect the similar topics, I just want to tell you that conjunction is like your AND gate, and or is disjunction is like your OR gate, right? So now take the exclusive OR, right? So the exclusive OR, right? Exclusive OR is denoted by this symbol, right? This is the symbol for exclusive OR, which is also known as XOR, right? It's like XOR gate. It's like XOR gate, right? In electronics, right? So the definition says that if P and Q are two prepositions, so the exclusive OR between P and Q, right? P and Q is true when exactly one of P and Q is true, right? Is true. Otherwise false. Otherwise false, right? So if we create a table for truth table for P and Q, so again there will be four combinations. If of true and false, it will be true, true false, false true, and false false, right? So here the exclusive OR between P and Q is denoted by this symbol, right? So the P's or Q is true when execute one of P and Q is true. So either P is true or Q is true. So there are two cases only, this one and this one. Otherwise, it will be false. So in other words, you can also say that when one of the inputs is true, then the P's or Q will be true. If both inputs are same, right? So it will be false. But if both inputs are different, it will be true. So in that case, here you can also see that P and when both P and Q are same, either it's true or both are false, then it is false. Otherwise, it is true, right? So this is the exclusive OR. Then we have another prepositions logic proofs, which is if P then Q, right? If P then Q. So another is conditionalist statement, which is also known as implications, right? Implication, or you can say that if P then Q, right? Implication. So which is also known as if P then Q, and the symbol is your P then Q. This is symbol, right? This is the symbol for this implication, and it says if P is true, then Q is true, right? So if I write a truth table for this, so again these two prepositions, the combinations will be true true, true false, false true, and false false. So many questions are asked from this. This is the very important, right? This is very important logic proofs. So P, if P then Q. So it will be like if P then Q. So if P is true, then Q is true, then the whole statement is true, right? Okay, again here, if P is true, then Q is false, then this whole statement will be false, right? So if P is false, then Q is true, then the whole statement will be true, right? And here in the last case, if P is false, okay, if P is false, then F is false, then the whole statement will be true, not the false, because this is false, then it implies that the whole statement is true. So you need to understand this concepts carefully, and it also known as P implies Q. Okay, it is also known as P implies Q. Okay, so let's try to understand again that or it says Q follows P, right? Q follows P, whatever, or if P then Q, it is that I just told you, and I want to recall this concept that Q follows P, or P implies Q, or if P then Q, all are the same. So again, read this as if P then Q. So if P is true, Q is true, then the whole statement, this whole statement is true. If P is true, Q is false, then the whole statement will be false, because Q follows P. So Q is false, then the whole statement will be false. So it doesn't matter the preposition P is true or not. Then the P is false, then Q is true. So it implies that it is true. So the whole statement will be true. Here both are the same, because if P then Q. So P is false, Q is false, then the whole statement will be true, not false. Okay, because Q follows P. So you need to remember this, right? You need to remember these concepts. Okay. Now the another interesting concept, which is equivalence concept, which says if P only if Q, right? If P only if Q, right? So we have this bidirectional statement, right? Bidirectional, bidirectional, right? So okay, bidirectional. Let me write it again. Okay, sorry for this spelling mistake. So now bidirectional. So bidirectional is means in both the directions, right? Um, so this is denoted as this, right? And it is also known as by implications, right? What? By implication. So if in exam they ask you that what is by implication, so you know that now that what is by implications, because sometimes it's going to ask you that uh, uh, that what is the truth table for by implications and what do you mean by implications, right? So let's without wasting a minute again, I just want to I just explain you this concept using the truth table so that you can easily find out. So here we have the four combinations. So as of now you have also remember these combinations as we have I have write it again and again in all the concepts, because P and Q two are statements and which can be either true or false. So these are the four possible combinations of by taking one of the true or both of the true or either the false or true, right? So the P if only if Q or by implication, so P only if Q or, right? So if only if, so as you I think you have idea that sometimes in our mathematics classes and schools they have told me or teachers told us that this is like if only if. तो आप इसको इस तरह से रीड करते हुए आए होंगे अब तक. तो यहाँ पर जब हम बात करते हैं तो इसका मतलब ये है कि अगर P ट्रू है और Q ट्रू है then it will be what? It will be true. और अगर P false है और Q false है तो it will be true. Otherwise it will be false. So this is it, right? So the definition says that the biconditional statement P if only if Q is true when P and Q have the same truth values. Okay, when the P and Q have the same truth values. So if the values are the same, so here in this if I say that this is the first case, second case, third case, fourth case, so if you closely observe this table, so when both P and Q are the same, right? So this P is true, Q is true, then this whole statement will be true. When P is false, Q is false, then whole statement will be true. Otherwise it is false. So this is your by implications or by directional statement, right? So this is it for this class, and but before closing this, I just want to show you that that in one of the exams they have asked you about this table that construct a table for this, right? This is the statement, and they have asked you about the construct a truth table for this, right? This is your P or not Q, right? P or not Q, and then it implies that P and Q, right? So they have asked you to construct the truth table for this statement. So for that, what you have to do first, you have to write all the combinations for P and Q. So P is right true. Likewise, that we have seen in our all the logic proofs that it is true, true, false, false, true, then false, right? False. Okay. So Here, this is a new concept like for you, because I have not explained it because this symbol is your negation symbol, and it is your negation symbol, and is also denoted as not, or read it as not, right? Means if it convert the meaning of prepositions. So not means the opposite. So if P is true, then it will be false. So here what we have to construct the truth table for this statement. So first of all, we must have this not Q. So just evaluate this not Q. So not Q will be, here is true, true is, then it will be false, false will be true, true will be false, false will be true, right? Then P or not Q, right? P or not Q. So if you remember this table, that the disjunction table, right? So disjunction table says that if one of the statement is true or both of the true, then it will be true, right? So we have to look for these two symbols. So P is true and F is false, so it will be true because one of the statement is true. So true true will be true, false false will be false, and false true will be true. And then P and Q, right? So here we have to find the P and Q, because we can only find the value the values for this whole statement when we have this value. So we have these values here, these values are here, right? If I write two double ticks, yes, then now we have this P and Q, right? P and Q, then P and Q will be, this is your conjunction table. So true true will be true, right? True false will be false, and false true will be false, false will be false, right? And then we have this, because this is directly we have not manipulated P and Q, just looking for these values P and Q. So we have to find the conjunction between the P and Q, right? Then finally we will evaluate for this, for all this statement P or not Q, and implies, right, P and Q. Okay, so okay, now for this we need this table, we need this table, and we need this table, right? And this one. So P or not Q, and then so it is if P then Q. So if this is true, then it is true, then it will be the true. If this is true, this is false, then it will be false. If this is false, then this will be true, right? If this is true, then it is false, then it will be false. So you must remember the concept of all the prepositions, all the logic proofs, whether it is conjunction, disjunction, and negation, and equivalence, and then if P then Q. So bidirectional and implications, right? So again in exams they ask you about to prove that whether these two are true or not, or prove that this is equal to this and all, right? So in my some of the videos in discrete mathematics playlist, I have discussed the questions, previous questions, and you can find there the various questions on these implications, right? So okay, now I bind up this lecture here, and if you have any query and you think that I need to improve something, then please let me know. Otherwise, prepare for your exams by watching these videos and again, so that your concepts will be much more better and clear. Okay, so thanks for watching. Thank you.